Hi, welcome to day one of Advent of Code. I'm going to be I'm going to solve all of them in WhiteSpace, which is an esoteric programming language which only allows integer operations, but aside from that has some quite useful data structures and is actually not that terrible for coding. Yeah, you'll see. Assuming you watch all 25, which would be insane. But anyway, let's have a look at the first problem. This is adventofcode.com. It comes out every year. How many years has it been on now? This is the 9th year. And there are 25 problems, well actually 50 problems, 2 every day. And this is this year's. It comes on the 1st of December, so here it is. Blah blah blah. There's often a lot of text before they get to the actual problem. So this is some sample input text here, and what they want to do is pull out the numbers 12, 38 and 15. So that's the first digit and last digit to form a single 2-digit number. So that's 12, that's 38, that's 15, and this, it's 77. The first and last digit are the same. Add them together, get 142. Okay, so let me just log in. Now, one of the problems of trying to solve this in WhiteSpace, or quite a few esoteric programming languages, is they don't have the ability to detect when you've reached the end of your text. So I will normally, in my inputs, cheat very slightly by adding a character or something to indicate that we're at the end. Let's have a look at the input. And let's see, it seems to just be lowercase letters and numbers. Is there an exclamation mark? There is not. Okay, so exclamation mark is going to imply the end of our input data. So let's copy this now. This is some code here for a WhiteSpace debugger that I'm working on, but I haven't actually had time to write it all yet. That's going to be tomorrow on day 2. So at the moment I'm just going to be I've started creating a virtual machine here that will do a lot of what we need a WhiteSpace machine to be able to do. So we'll work with that for the moment. I think here I have a sample program that I wrote while I was putting this together, which prints out the numbers 1 to 10, and we'll just work in here for now. From tomorrow we'll start doing it properly, but let's see what we want to do. So essentially all we need to do here is set up a loop where we read in a character, see if it's a digit. If it's a digit, deal with it. See if it's a new line. If it's a new line, deal with it. See if it's an exclamation mark. If it's an exclamation mark, end and print out our answer. So let's start with that. Let's say we're not going to use the heap. We're not going to use the heap. Because that just makes things too easy. So let's just purely use the stack for now. So we are going to push onto the stack at the start 3 numbers. We're going to push 0 onto the stack. This is our total so far. We're going to push -1, which will be the first digit on the line. -1 means we haven't seen a digit yet. -1, which will be the most recent digit. -1 again means we haven't seen a digit yet. Then we are going to, that's it, that's our data structure set up. So now we are going to label start. No, that's called mark, okay. So this is the start of our loop. Then we are going to read a char. Maybe turn Copilot off so it doesn't seem like I'm cheating here. So yeah, we want to check if it's one of three things: a digit, a new line, or a exclamation mark. So let's do that. We will duplicate it. We will push 10, and we will subtract. So push 10. We'll subtract. And we will go to if zero a label that we will add called new line. So what we've done there is we've read a character. So the stack is now character, recent digit, last digit, first digit, total. We duplicate it, so there's now two characters on top. We push 10, we subtract. So the stack is now char minus 10, char, and so on. Then we pop char minus 10 off, we go to if zero new line. So if we've read in a new line, which is character 10, I know this, then we'll jump to new line. So, what do we want to do next? We'll check if there's an exclamation mark. We'll do the same thing. Copy and paste does wonders here. And then we'll go to exclamation mark. Otherwise, we will check to see if it's a digit. Now, I happen to know that the ASCII codes for digits are 48 up to 57. If you didn't know that, print ord 0, print ord 9. Just check that I'm right about the ASCII code for exclamation mark being 33. Yep. Okay, so let's check if our number is between 48 and 57. We've got go to if negative as the only comparison in our language. So what we want to do is duplicate it. So this series of lines here takes our character, makes a copy of it, puts 33 above that in the stacks, pops the two off and subtracts them, so you now get character minus 33, then pops that off and says go to if zero. So if we hadn't duplicated at the start, we would now not know what our character was, which wouldn't be very useful. So that's why we're duplicating. Okay. So yeah, comma. So then we are going to push 48. And I would say we're going to subtract. Basically, we want to jump to not a digit if we're less than 48. So if we were to subtract, we'd get a negative number. Yeah, that's exactly what we want. Subtract none. So now the top thing on the stack is our ASCII code of our character minus 48. If that's negative, that means the ASCII code is 47 or fewer, which means that we're not a digit, so we go to not a digit. And then we'll do the same, but for 57. But here we don't want to check if character minus 57 is negative. We want to check if 57 minus character is negative. So we will swap the order of the top two things on the stack. So now we have character 57. Wait, what does subtract do? The first item pushed is considered to be the left. Oh yeah, okay, so yeah, so I was right. Here the stack is now character minus 48, character dot dot dot. So if this is negative, we indeed have not a digit. Stack is now 57 minus char. So if this is negative, then char is at least 58, and so we are not a digit. Okay, so if we reach this line of code, that means we know that we've got a digit. So what do we want to do? Well, the first thing we want to do is the first thing we want to do is subtract 48 from it, so we get the actual digit, not the ASCII code. Okay, now what? Now our stack, I'll take the whole one, this is now digit, latest digit, first digit, and our total. Well, the first thing we want to do is we want to replace last digit with the current digit, which we can do by swapping them, dropping the last digit, and duplicating. Often called drop. And why haven't I called it drop? Pop. Yeah, see the logic, but nah. Drop is going to work better for me. I swap, drop, and I dupe. So what happens is we get last digit, digit, first digit, total. Then we get rid of the previous last digit. And then we've duplicated it, which means now we've replaced the second position on the stack with another copy of digit. Now what we want to do is see if first digit is -1. If it is, we want to replace that too. So how do we do that? We have the delve command. So we are going to delve for the third item on the stack and hope that it's not 0 counted. I guess we should check this. Well, we'll check in a bit. How are we going to slide n items off the stack, keeping the top? Yeah, that will work. Okay. Check whether delve and I think I call them delve and shelve. No, delve and discard, but I like delve and shelve. Let's call them delve and shelve. We will check if delve and shelve are what's called 0 beginning. can't remember the word, but whatever. So we're going to delve 3, and that will give us first digit, 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 first digit, total. And then we will go to if negative, first digit. So this will pop fdig off the top of the stack, and it will pop fdig off the top of the stack, and it will go to first digit if it's negative. If it's not, if we get to this line, that means first digit wasn't negative, which means we're done. And we go to start. Oh no, we drop the copy of the digit that we've been keeping around. So we now have digit fdig total, and we go to start. So you always, when we get about to start, want the stack to be last digit, first digit, total. Right, so let's mark here first digit. Now, suppose there is a first digit. Suppose this is the first digit. Then we want then the stack here is now digit, digit, fdig, total, well, -1 in fact. And we want to get rid of the -1. So I think shelve 2 says slide 2 items off the stack, keeping the top item. I think it's going to be slide 3. Shelve 3, I think that means we will then have digit total. We need to check exactly what the parameters to delve and shelve do. We'll do that later. Then we dupe. We have digit, digit, total, and we are where we need to be to continue. Go to start. Right, now, interesting point. We have a new line. So we know that on the stack we have the latest digit, the first digit, and the total. And what we want before, when we go to start, is we want to be back to -1, -1, total plus 10 times first digit plus last digit. So let's do the multiply by 10 first. We'll swap. We'll push 10. We'll multiply. Then we will add, then we will add. Finally, we'll push -1 twice. And we will go to start. In the case that we don't have a digit, actually let me check, when we got to new line, what was on the stack? Go to new line. Stack is now char -10 char. Oh, we had the char there. Okay. So the stack was actually char ldig fdig total. So first thing I want to do is drop the char. In fact, we know that the char there was 10. Then we've got to go to start. Yeah, it's a mark, not a digit. If we jump to not a digit, we again have our stack is char ldig fdig total. So we will drop the char, and we are ready to go to start. Finally, if we have an exclamation mark, we know the stack will be hash 33 ldig fdig total. We're going to put the exclamation mark on a separate line, so actually it'll be 33 minus 1 total. And what we want to do is drop the first three things on the stack. Then we want to print the number on the stack. Does that pop it off the top? I don't know, we'll check. I mean, it doesn't really matter. I like to leave my WhiteSpace stack empty when I'm done, but we don't need to. But this should do what we want. However, I haven't actually implemented all these programs yet. But let's take in the sample input and check that we get 142 at the end. That R. Is that? Yeah. There we go. Let's see what we get. I mean, it'll say, don't know how to read a character, I guess. Go to start. Okay. Need to remember my commas. This will be a lot easier once I've written my debugger. But wait, where is it? Virtual machine has no attribute input. Okay, yeah. So how have I implemented read? That's in this file. Bear with me. Read char and read number, they can't do the same thing. I'm going to say this is on the virtual machine to do. Right, virtual machine, how do you read a char? We've got an input list of characters and an input pointer. Okay, well that's going to be easy then, isn't it? Def read char self, if self dot input pointer is greater than len of input list, raise an exception saying reached end of text. Otherwise, return self.input list. Right, we'll say the response is this, then we'll increment the input pointer, and we'll return the response. And it's telling us off for not putting a colon on there, which is fair enough, I think. So let's try that. Unsupported operand types for minus int and str. Yeah, I mean, fair enough. Why is there a string on the stack? Read char. Right, what am I doing here? Oh, I want to return odd. Okay, go to if negative. Did I already write go to? Yeah. Go to if negative. What I will do is if self.pop is less than 0, self.goTo label. Oh yeah, much like goTo if 0 down there. Now I should have Copilot on while I'm doing this bit. Minus 44. Perfect, except for, you know, being wrong. But at least we're coming out with a number. So what have we done wrong? Now, ideally, we'd be able to debug into this. In fact, we can, because this is Python and Python is debuggable. So let's do that. Let's put a debugger on. Yeah, in the virtual machine on. Yeah, let's start here. Let's see what happens when we run our program. I will. Can we make a copy? No, we don't need a copy. I'll put this over here for now, so we can see our program and see what's going wrong. Debug. Okay, so we start off with, well, let's put the breakpoint there so we can see what the instruction is. Or can we? Yeah, we can. So, push 0 as expected. Let's look at the output list. Well, let's look at the stack each time we go through and check this, Jim. We want to push 0, push -1, push -1, mark start, nothing happens. Read character, which should be 49. Sure. Duplicate it, push 10, subtract. Okay, we've implemented subtract wrong because it said here that that the first item pushed is considered to be left of the operator, not the first item popped, the first item pushed. So where is OBN instructions? Which is here. Subtract. Can you braces? No, that's going to return a set, isn't it? No, you can't. Okay, fine. Let's not then. Left hand is VM pop, return LH, no, VM.push LH minus RH. And while we're at it, we will, where's that being highlighted? What's wrong? Is it that we need space? While we're at it, we'll do def division function. With addition and multiplication, it doesn't matter because they are commutative. But here we will push LH divided by RH. I'm sure it'll bother some people that I've called one of them subtract and the other one division, and they're not the same part of the verb, but it doesn't bother me. So there we are. No brackets. Okay, let's just try running and see if we get 142 now. No. Oh, interesting. Why's that happening? Okay, let's debug. That's what we care about. Right, where's our program? new watch, self.stack. Push 0, push -1, mark, read in for 9, duplicate, push 10, subtract, get 39, go to new line F0, it isn't, duplicate, push 33, it isn't. Okay, now we try and find out if it is a digit. So we go to 0, we duplicate, we push 48, we subtract, we go to if that's negative, but it isn't. So then we duplicate again, push 57, swap, subtract, go to if negative, not a digit. So now we find out what digit it is by subtracting 48. Then we swap, drop, duplicate, yep. We delve 3 to find out if we've got -1. We go to if negative, first digit, it is. So now we shelve 3. I have not implemented shelve. What does it think the instruction is? Mark, first digit, yeah, okay. Next, it thinks the instruction is discard. Have I implemented discard? I think I've implemented it correctly if I have. Oh, it's here, instructions. vm.discardn, discard. So actually, I think how I'm trying to use shelf 3 is get rid of the second and third things on the stack, keeping the first thing. Is that right? Where was it? Shelf 3, digit total. Yeah. So I want to get rid of the second and third things while keeping the first. So that would be previous top is self.pop. Self.stack is equal to self.stack minus colon minus n plus 1, n minus 1. So let's say n is 2. We're trying to delete one element. So this would be stack colon minus 1. So everything but the button. Yeah. Plus prevt. Okay. Let's try run again, see if we get 142. Yes. Boom. Okay. Now what we will do is translate this into actual whitespace and run it over here on IDE 1 and check that we get the right answer. That's the quickest way to check that Delve and Shelve are doing what we want. I guess I could write programs individually to check them, but let's start with that. Let's bring instructions back into the fold. Yeah. And what we're going to do is we've got that series of instructions. We are going to output it as, so let's have a compiler directory here. Compiler.py. Am I going to call the yeah, so the whitespace version will be compiled and the plain text will be decompiled. So this is the compiler. Compile instructions for inst param in instructions. Let's just start with print inst param. Instructions, instead of VM run VM get output, we're going to say, in fact we're not going to make the virtual machine for now. We are going to say print, we're going to say compile instructions. compile is a function we already have. From WhiteSpace.compiler import compile. Right. Not very informative. Let's print instruction dot. Do our instructions have? Our instruction has compile text, decompile text, and is marked. Let's start with. Fine, let's just do compile text inst.param. I'm turning. Where's it gone? I'm sure it was right there. Oh, here. I'm turning Copilot back on. So you'll see there's lots of white space here and the type of parameter. Print int. Okay, in fact. Output text. I'm gonna append the compiled text. Then if inst.parameter equals parameter.none, yep, we'll import that. Then continue. If inst.parameter equals parameter.number, pass. If inst.parameter equals parameter.label, pass. And then at the end we're going to return, yeah, exactly as it said. Okay, so how do we write numbers? Many commands require numbers or levels of parameters. Numbers can be any number of bits wide and are simply represented as a series of space and tab terms by LF. So it's in binary. The sign of a number is given by its first character, space for positive and tab for negative. Okay, so sign equals 1 if parameter. Yeah, that's good for me. So the first thing we do is, well, okay, let's say output text dot append space is positive, space if param is greater than or equal to 0, else tab. Yeah. Then we want to translate absent param into binary. Use Copilot, use Copilot. I've got Copilot here. Okay, let's have a look. Print in 33. See what the 2 colon is. Yep, okay, so we get rid of the 0b from the start, and then we just translate the characters, I think. Well, let's have def convert number num. Opening is space if num greater than 0, otherwise it's tab. Yep. Then bin is, no, B is the number in binary. Return opening. Yeah, exactly that. Zeros become spaces and ones become tabs. Great. So output text dot append convert number of param and a new line at the end. There we go. Labels are simply, okay, line feed terminated list of space and tabs. What we'll do for now, we'll come back to this, but for now we'll just use the shortest label we haven't used yet. So global, well, mark it as global elsewhere. First, next label is space. So response is K for K and next label. Could probably just use next label there. In fact, yeah, we definitely can. It's going to copy it. Next label plus, in fact, join next label plus n. Now we want to change to the next label, where we're going to essentially go through in what's called alphabetical order, lexicographical order, and if once we get to the all tab string, this is lexicographical, assuming that, in fact, no, let's do proper lexicographical, so tab is before space. So once we get to the all space string, we then replace with tab with an even with one longer. So if tab not in next label, global next label. Next label is equal to this. Otherwise, what do? We find the last. So if we've got a tab at the end, then we're just going to turn it into a space. So we find the last tab. I is len of next label minus 1, while this is space, we decrement 1. Eventually this will stop because we know tab is in next label. So we've got a tab here, so we're actually going to say next label is next label up to I plus a space plus that looks right. Oh, we want a dictionary as well. Because if we try and convert a label we've already converted, we want to get the same answer. So let's start there. If param in param dict, return param dict of param. Otherwise, at the end we store it in the dictionary and we return it. Now let's, from WhiteSpace.compiler import convert label. Convert label 1. think we'll restart. From compiler, import convert label from WhiteSpace.compiler. Import convert label. Convert label 1. Convert label 2. Convert label 3. Convert label 4. There should be a tab, obviously. Let's copy this. I in range 10, print, no, else. Convert label 1, convert label 2, convert label 3, convert label 4. I'll check the dictionary is working. Okay, that's good. This might work. Who knows? Let's find out. Instructions. Let's code equals compile instructions. Open temp.whitespace .write code. See how this goes. Okay. Let's look at that whitespace code. Gorgeous. Copy it, paste it into here, paste in this with an exclamation mark at the end. Not very confident, but it's a good start. Does it not know that I typed anything in there? That's the source code. Interesting, stack space overflow. Okay, well let's start with some easier instructions and see how they work. Let's just do instructions equals push 10, push 11, print number, exit. Much shorter program. Okay. So that program is doing what we want. Now let's do let's check about delve and shelve. Push 12, push 13, delve 2. Let's print the top 3 numbers from the stack. So if it works the way I think it does, delve 2 will mean the top 3 numbers would then be 12, 13, 12. Let's have a look. 11, 13, 12. Okay, good to know. So it delve 2, so this would be delve 0 is the same as duplicate. So now let's do shelve 2. Let's make an even bigger stack. And let's shelve 2 and see what the top of the stack looks like. So delve 0 is the same as dupe, that's one thing we've discovered, and let's see how shelve works. Come on. 13, 10 and 9. Let's think about that. Okay. 13, 10 and 9. So shelve does work the way it works. It removes two things but keeps the top thing there. Okay, so is that what I implemented shelve to do? Yes. So shelve 3, no, I've made it so shelve actually, this should be a shelve 2 and shelve 2 should do what shelve 3 was doing. That explains why it was crashing, because it was getting rid of too many things. Yeah, so VM discard is the one that we should change. It is supposed to actually get rid of n things. And finally, delve doesn't do what I thought it did. How am I using delve? Yeah, delve 3. Yeah, delve will actually get the total here, which will never be negative. So we want this to be delve 2, and we want delve 2 to do what delve 3 did do. VM.delve. So if we say delve 1, that's the same, delve 0 rather is the same as dupe, which clearly would be now. Delve 1, yep. Okay, so maybe we'll try again? Yeah, let's do that. Well, in fact, let's do both. Why don't we have both? There we go. Run 142 and our beautiful source code. Stack space overflow. What am I doing wrong? I'm assuming it only, well, I'm not even trying to output anything. Let's see if I can output debug information here. Push 10, print number. Okay, so I can output debug information if it would help. I guess I could at least see what characters are being read. Yeah, let's start with that. So when I read a character, I'm going to duplicate it. I'm going to print the number. I'm going to duplicate it. No, I'm not going to duplicate it. I'm going to push 10 and I'm going to print char. Here's what I think should happen over here. What? Read char doesn't work. Okay. Let's check that. Instructions equals read char none, print number none, exit. This should just print out the number 49, right? Yeah. User error, can't do read char. Interesting. Oh, that's because read char uses the heap, doesn't it? What an idiot I am. Oh well. Yes, read char places in the location given at the top of the stack. Yeah, well that'll do it. So I do need to use the stack after all. So where I have read char, oh, let's first change the implementation of read char. Have I even implemented the stack yet? Store and retrieve. No, okay. Right, well let's do that then. Store is instruction lambda vm.store parameter.none. Store is tab space. Retrieve is instruction lambda vm.retrieve tab, yep. Def read char function vm.push vm.read char vm.store def read number function vm.push vm.read number vm store. So read char function and read number function. So what read char does is it takes the top thing off the stack and stores in that heap entry. Yeah, stores in the heap in that location the character. So what we're going to do is push 0, read char, push 0, retrieve none. See how this goes. It won't go well because I haven't implemented the heap yet. Virtual machine. Do I have a heap? Yeah. Well, it's not difficult to implement. Def store self value pop address pop. I think it's the wrong way around. To store an item, push the address and then the value. Yep, and run stock one. That is correct. Yep, Copilot knows WhiteSpace. Weird, but fine. I think that should work. Okay. Where? Oh yeah. That's because that's the error I was doing. Yeah, so if I push 0, read char, push 0, retrieve, I should then print 49, and the WhiteSpace version, here we go. Yes. Okay, well, let's try the program we wrote. And it prints out 142. Let's get rid of printing out the... Well, let's try it first. If it works, then... Yeah. Let's get rid of the printing out of the characters, because the actual text is quite a bit longer than the test text. Where were we? Yeah. Dupe print number, push 10, print sharp. We don't want those instructions. We just want the number 142. And if we run this, we've just got the number 142. Great. Let's get our puzzle input. There it is. And let us change the input and run. Five, 4, 5, 7, 3. How confident are we? I'm fairly confident. Let's try it. Yes. Now we get the second part of the question. Okay, so we're looking for the first text number and the last text number in each row. Wait, what? Oh, they all count as valid digits. So the last line is 7, 6. Okay. This is sufficiently more complicated that I think we're going to make it a second video. But we've got 1 star already. Thanks for watching.